Okay, next is question number 15. Okay, in question number 15, the question says in a high jump competition, athletes jump over a bar. Okay, an athlete has a weight of 680 Newton. So part A here it's asking the athlete exerts a force of 890 Newton on the ground as he jumps into the air. So as the athlete is jumping into the air, it is basically exerting a force of 890 Newton in the downward direction on the ground. Okay, so explain why the athlete accelerates upwards. Your answer should refer to Newton's third law. Okay, Newton's third law. So Newton's third law says what? Every action force has an equal and opposite what? Reaction force. So basically, when this athlete is exerting 890 Newton force on the ground, by Newton's third law, this ground will also react to that force in the upward direction by the same magnitude, right? So what we can write here, change the size of the ink. Okay, so by Newton's what? Third law, the ground will what? React, isn't it? Will react to that force in the upward direction by the same magnitude, right? By the same magnitude. Okay, so if the same magnitude of force X on the what? On the athlete, the ground will react to that force in the upward direction by the same magnitude. Okay, so a force of 890 Newton is acting on the athlete, right? When Newton's third law, the ground will react to that force on the athlete in the upward direction by the same magnitude. So 890 Newton, it is what? Greater than what? 680, the weight 80 Newton. Therefore, what? Resultant force is towards the what? Since 890 Newton, it is acting in the upward direction. The resultant force is towards the upward direction. Upward what? Direction. Okay. Hence, resultant acceleration is what? Resultant acceleration will be exactly towards the direction of the resultant force, right? Is upward. That's it. That's the answer for number 15A. Fine. Okay, next is number 15, part B1. The athlete moves horizontally as he passes over the bar. The kinetic energy of the athlete is 409 Joule. Show that the athlete has a horizontal speed of about 3.4 meter per second. Okay, so when the athlete moves over the bar, the athlete is basically moving what? Horizontally. So we need to find out the horizontal speed. The kinetic energy is given, so we can, if the mass is known, the mass of the athlete can be found from the what? Weight, right? So mg, the weight of the athlete, it is equals to what? 680 Newton. 680. So mass is how much? Mass is 680 over g kg, that much kg. Okay, so half mv square, half of mass is how much? 680 over g times what? V squared. This is equals to 409 Joule. Okay, so Now we know the kinetic energy, so we can easily find out the speed using the calculator. 409 times 2 over what? 680 over 9.81. So this will give you 11 point something, then square root the answer. You will get the speed. It's basically 3.435236956 meter per second. Okay, so horizontal speed is what we can say. Okay, the horizontal speed is 3. V, it can be written as 3.4 meter per second. Okay, that's what the question of 15B1 has asked for. Fine. Okay, next is question number 15B2. After passing over the bar, the athlete moves through a vertical distance of 1.4 meter before he lands. Okay, so since the athlete has to jump over the bar, so the athlete is basically covering a vertical distance of 1.4 meter before he lands. Okay, calculate the velocity of the athlete as he lands. Okay, so basically after passing over the bar, the athlete moves through a vertical distance of 1.4 meter. Okay, so as the athlete jumps over the bar, he is reaching a vertical height of 1.4 meter. Okay, so from that height, the athlete will fall freely, right? So consider the vertical motion, take up downward is positive. So at the maximum height, because from while jumping, the athlete will be falling from the maximum height, right? So from the maximum height, initial speed will be 0, right? Final speed, we need to find out the speed with which he will hit the ground vertically. Okay, this is the vertical component of final velocity. You can say it's the vertical component of final velocity. Acceleration is it's equals to g, distance is given. Okay, so we can use this formula, v square equals to what? E square plus twice of as. So we need to find out v. So v equals to what? Square root of 2g. H is how much? 1.4. So the speed would be, this is the vertical, v vert. Let's say this is v vert, vertical. Okay, okay, this is square root of 2 times 9.81 times 1.4. That gives you 5.240992272 that much meter per second. Okay, this is the vertical component of final velocity, and we know that the horizontal component of velocity, we found it earlier, it was how much? 3.4 meter per second. Okay, so it's 3.4 meter per second. So magnitude of, they wanted the velocity. Okay, so magnitude of velocity, it's what? We have to use the Pythagoras, right? Pythagoras theorem. So 5.24, the vertical component squared plus the horizontal component squared. So horizontal component was the exact value, it was 3.435 something. Okay, so 3.43 something whole squared square root, right? Just the Pythagoras theorem. Okay, so the vertical component of velocity, final velocity, it is saved. So it is answer squared plus what was the horizontal exact value for the horizontal speed? It was 3.435236956 squared. And then square root of answer, that would give you 6.26648 6491 meter per second. Okay, this is the magnitude of velocity. Now we need to figure out the angle, right? So for finding the angle, since it's falling vertically, this is the vertical component of final velocity, and the horizontal component of final velocity, it's basically along this way. So let me erase this one. So this is v vert and this is v horizontal. Okay, so we need to find out the angle from vertical. So that means this is the vertical, right? This is the vertical and this is the angle theta. So let's use tan theta, trigonometric ratio. Tan theta equals to what? Horizontal component of velocity, which is 3.43 something over what, 5.24 something. Then you will get the angle theta. So let's calculate it. So the horizontal component of velocity, it is 3.435236956 over the vertical component of velocity, it is 5.2409922272. Okay, so then use tan inverse answer, you will get the angle in degrees. It is basically 33.24305601 degree. So magnitude of velocity up to 3 significant figures, we can write 6.27 meter per second, and angle from vertical, you can say 33.2 degree. That's it. That's what part B2 of question number 15 has asked for.